Hello, this is Mrs. Nearing, and in this video we are going to talk through some mole calculations. Hopefully this will be a little bit of review from regular chemistry, and there is practice and there's some reading to help you through this, but I also wanted to make a video as well. So when we're talking about mole calculations, we are just using this mole concept, the idea of this mass ratio, to help us solve problems such as these two examples. So how much would 5 moles of magnesium weigh? So this would be doing a, mole to mass conversion. And then the other type would be how many moles are in 21 grams. So doing a grams to moles conversion. And these calculations are using the molar mass, which can be thought of as, it's a mass ratio. So it tells us how many grams are in 1 mole of a substance. And this method is using what we call dimensional analysis, which I am going to model. And I can also post some videos that I have from general chemistry, just kind of reviewing the concept of dimensional analysis. It's a helpful strategy. You also don't have to solve problems in this particular way. You just have to show your work and what you're doing. So like an example of an alternate method would be to use this formula from your equation sheet. You can treat this like an algebra problem, whereas you can say the moles is the mass divided by the molar mass, and you can rearrange it and solve for your unknown. You can also set up problems like this as a set of equivalent fractions, which maybe I'll show you an example like that to begin with. So all you need to do is show your work. Okay, but dimensional analysis is a useful problem solving strategy, so I recommend giving it a shot if it's something you're not already comfortable with. Okay, so we're going to be using our periodic table. The periodic table, you can find it in the course resources section, and you can flip back to that. I believe in there I put in a printable copy if you happen to have a printer and wanted to print it out, if you found that easier. And if you would, yeah, so there you go. We're going to be looking at this periodic table. So let's look at this. We're going to start with this type of conversion. We have mass and we're trying to figure out moles. So we won't go through all 4 of these. We'll just pick a couple. So the question is, for example, for A, if you have 11.8 grams of argon, how many moles is that? So I'm going to first look back at my periodic table, and I'm going to look down here at argon, and I'm going to look at the number below here, and that is the molar mass here, 39.95. So 1 mole of argon weighs 39.95 grams. That is what that number there on the periodic table that I just looked at is telling me. Okay, so I'm going to show you how you might set this up using equivalent fractions, if that is something that would make sense to you. So what you could say is 1 mole of argon is 39.95 grams. So X moles of argon, that's my unknown, would weigh 11.8 grams. So that's one way of thinking about setting up this problem. You can set up 2 fractions that are equivalent to each other. This is your unknown you're trying to solve for moles. When I do this, I'm going to rearrange this by multiplying both sides by 11.8 grams. And then I'm going to rewrite this in a way that looks a little neater. And what I end up with is 11.8 grams of argon multiplied by this fraction, which is what we call our conversion factor, that says for every 39.95 grams of argon, I have 1 mole of argon. You see how this looks like that example of what I call dimensional analysis on that previous page? So that's where this derives from. You can think of it as coming from this idea of equivalent fractions here. And so when you are setting up dimensional analysis, what you want to check for is that your unit here that you're starting with matches the unit on the bottom of the fraction, because we want these units to cancel out. Units that you're left with, that's what your answer is. So I'm going to plug this in my calculator, 11.8 divided by 39.95. And before I write down an answer, I encourage you to always kind of do a little bit of mental math, check your answer for reasonableness. I know 1 mole is 39 grams, and I only have 11.8 grams, so I seem to have less than a mole. So you always want to do some mental math because sometimes we make mistakes plugging things in the calculator. So you want to kind of think, does my answer seem reasonable? So when I look in the calculator, it gives me 0.295366921. I'm going to round this to 3 sig figs, so 0.295, because this measurement has 3 sig figs in it. And this value has 4 sig figs. So my answer will have 3 sig figs in it. So now that we know the sig fig rules, we can practice those while we're calculating. Okay, let's look at one more. So this one, 0.211 grams of Li, that is lithium. I'm going to set this up using dimensional analysis. I'll show you how to set this up. So what I know, since I've got grams lithium over here, I want grams lithium to go on the bottom, and I want to convert grams lithium into moles lithium. That's what I'm trying to find. So this is what we call a conversion factor. It's something where we have a known relationship, and where we find this relationship is on the periodic table. So if you look back over here at your lithium, what the periodic table tells us is that 1 mole of lithium weighs 6.94 grams. So 1 mole of lithium weighs 6.94 grams. So 0.211, again, I'm going to do this real time in my calculator. Okay, so I end up with 0.0304 moles. The reason why I wrote it this way is I want to have 3 sig figs in it. These leading zeros are not significant. So leading zeros are not significant there. So that value has 3 sig figs in it. All right, now let's try one doing the opposite, going from moles to mass. Let's start with this one. What if we had 0.0355 moles of barium? I'm going to set this up using dimensional analysis. And when I do this, like you might have noticed in the last problem, what I do is I fill in the units first before I start filling it in numbers. So I'm starting with moles barium, and I want to convert moles into grams. So in my conversion factor, I want moles to be on the bottom because that's the unit I'm trying to get rid of. I want grams to be on the top because that's the unit I'm trying to find. And this relationship is a known relationship that we can find on our periodic table. So I'm going to go back again to the periodic table. I'm going to find barium. It is right over here. And of course, I know some of you at home might just actually Google these masses as well, but it's good to get used to knowing where things are in the periodic table because you will need to be able to find them. So there's barium. Its molar mass is 137.33. Okay, so that means 1 mole is 137.33 grams. And so I'm going to multiply 0.0355 times 137.33. And I want to round my answer to 3 sig figs because this number has 3 sig figs and this number has 5 sig figs. So based on my sig fig rules, my answer should have 3 sig figs. And my answer is 4.875215. I am going to round that to, 4.88. So the rule is 5 or higher, round up. So that 7 becomes an 8. Okay. So that's an example of a moles to mass one. Let's look at another one. Let's look at moles to atoms. This is a less common example, but let's go over it just for the sake of knowing the concept of the mole. This is something you're not likely to actually run into in a practical situation, like in a lab or on a test. But let's look at this one. So let's say you had 5.52 moles of sulfur, and I want to figure out atoms. So if I'm using dimensional analysis, I want to convert from moles of sulfur to atoms of sulfur. So in general, with dimensional analysis, the way I think of it is there's a value that you start with, and then let me write it this way. You start with a value that has some, that's your given, it has some units, and then you want to convert those units that you have into the units that you want. So we have moles, we want atoms. So what you want goes on the top, what you have goes on the bottom. That's another way of thinking about dimensional analysis. All right, and do we know this relationship? Yes, 1 mole of sulfur has 6.02 times 10 to the 23rd atoms. Do you need to memorize this value? No, this is found on your equation sheet, which is also found in the course resources in the content library. So you can find that there. And when you're plugging this in I don't know which calculator you're using, but you want to use one that has scientific notation capabilities. I know I use my phone all the time. I've got a scientific notation calculator there. There's various ones. Maybe we can share out good ones. Maybe there's some good ones you can use on your laptop. You probably have a graphing calculator from math class, maybe. But let me know if you have questions on what kind of calculator to use. There are some cheap ones that are very good. And there you go. That would be how many atoms there are in about 5 moles of sulfur. Let's look at another example. What if we're going from grams to atoms? Again, this is not as common, but this is kind of a fun one because it's a 2-step process here. So if you think about here, we want to go from grams to atoms, but we don't know a relationship between grams and atoms. We do know a relationship between grams and moles, and we know a relationship between moles and atoms. So what we can do is we can do a 2-step process. So if we have 5.18 grams of phosphorus, we can convert grams of phosphorus into moles of phosphorus. And then once we know moles of phosphorus, we can find atoms of phosphorus. So that's a 2-stepper, okay? We know that 1 mole of phosphorus is 6.02 times 10 to the 23rd. And then this mole to gram relationship, remember, we find by looking at our periodic table. So I'm going to flip back to the periodic table. Phosphorus is over here. Its molar mass is 30.97. So 1 mole of phosphorus is 30.97 grams. Make sure you put those numbers in the right place. So 1 mole is 30 grams, not 30 moles is 1 gram. So the number from the periodic table should always go next to the gram unit there. And notice your grams cancel, your moles cancel. You're left with an answer that is in atoms. I can plug this in my calculator for you. 5.18 divided by 30.97. 30.97. And then I'm going to multiply it by 6.02 E23. And I end up with, what's the fun one for rounding? 1.01 times 10 to the 23rd would be rounded to 3 sig figs. The other thing I should say about this value, if you're going to plug it in your calculator, if you're not familiar yet with this E button on your calculator, you might see something that looks like this, capital E, capital E. It looks different on different calculators, but I would highly recommend using this number. I guess not really a number, but this symbol right here stands for times 10 to the. So you can press one button instead of pressing times 10 caret 23. It's a lot faster and less error prone, and I can help you figure that out if you're not sure how to do it. Okay, so thanks for watching. I hope this was helpful. Let me know if you have additional questions.